All right, now we're going to talk about charging by induction, as it says here. And charging by induction is a little more subtle. It's going to take a little more explanation to explain exactly what is going on. To start us off, we are going to start by assuming we have an object. In this case, I'm showing a positively charged strip like our acetate or glass strip, maybe rubbed with silk, so charged by friction, so it has a net positive charge. Now, that's going to be the inducing object, okay? The object that's going to ultimately be charged by this induction process is the sphere over here. So this sphere is going to end up being permanently charged if we do it right. So let's see what that means. Well, charging by induction will always be involving a grounding wire that is going to ultimately be connected and disconnected to leave the object permanently charged. Now, as it says here, when you're looking at charging by induction, you want to focus on the coupled system, meaning the already charged object and the object that is going to become charged. So the already charged strip and then the object that is going to become charged, our sphere. Now, the two together have a net positive charge. So what you want to think of as ground being the great neutralizer. Ground will neutralize this coupled system, which has a net positive charge. So that's what's telling me that electrons are going to flow upwards to the sphere. Now, the positively charged electrons will attract the electrons in that conducting sphere and polarize the sphere. We haven't talked about voltage or why it's so, but just know that it does not matter where the ground wire touches the sphere. We can touch it right in the middle, we can touch it up closer to these negatives, we can touch it down here by the positives. It does not matter. The same thing will happen. We look at the coupled system. The coupled system is positive, electrons are going to flow up. Now, if we cut the wire, right, get scissors out, cut the wire, then we've trapped the electrons on, they remain negatively charged. If, as it says here in part A, before cutting the wire, we pull that positive strip away, well then the electrons are going to flow back to ground, and then the sphere would be neutral. So those are the two ways that kind of this situation is presented to students. It's called induction, the charging process, because it's the positively charged pink strip that is inducing these electrons up from ground. So no touching. So no touching, inducing, induction, up from ground into the sphere. Okay. The other type of question that we have is looking at polarization. So this is not charging by induction, this bottom half of the notes here. This is just looking at, well, what can we say about a system when we have one object charged relative to observed motion. So this part would be more for you as a student based on a multiple choice concepts type of a question. So let's see what's going on. In part A, we have our positively charged glass rod brought near to this neutral metal sphere, and we're told that no electrons can flow through the thread, so we do get this polarization that we just talked about. The electrons in the neutral metal ball are pulled over here. The electrons are closer to the positive, so positives and negatives attract. The ball can move over. So in terms of what can we say for sure, or what can we say, we can say that the ball could have been neutral, and polarization could have let the negatives become closer and move in there. Of course, the ball itself initially could have been negative, right? So it could have been negative. I know it cannot have been positive. So could be net negative, can't be positive, but polarization also could have done it. Now, what if in part B here they're telling us that the ball actually repelled? Well, if the ball actually repelled, then polarization is not the answer. And definitely highlight, get this into your notes. Polarization never explains repulsion. So the only way you can get repulsion would be that the ball was indeed positively charged, and then the positively charged strip that was brought near it repelled. So just a couple of little more subtle points in terms of conceptually what we're talking about, and then as a final note to our notes in this lesson, we go on to our next page here, where this is an old comic strip cartoon, like from the newspapers, where this artist obviously had a background in physics, where if you've ever played with balloons, especially in the wintertime, they might get kind of a little electrostaticky and stick to the ceiling. Well, the reason they do that is a situation similar to what happens here. Obviously not babies, but if we want to think of these as baby balloons, if you rub a balloon against your sweater, you can take that rubber balloon will take electrons off your sweater, just like that rubber comb takes it off your hair, and they become negatively charged. If you then reach up and touch them to the ceiling, believe it or not, the paint, that latex paint in your ceiling, will partially polarize on the edge of the ceiling. So all those electrons and the electron clouds around the atoms in the ceiling begin to bulge in the direction away from the ceiling, leaving a net positive, and they can stick for a short period of time on the ceiling. So I realize that, it's a cartoon, it's silly. We are certainly not trying to stick anything other than balloons on the ceiling, but if you understand physics, it's kind of funny if you think about it. So that was our lesson on induction and polarization, and we can talk more about this in class if you have questions.